Hello guys, welcome back to Testing with Harshal. In today's video, we are going to learn about the software development life cycle. Before starting the video, please do hit the like button if you liked the video. This tutorial will give you an overview of the SDLC basics, SDLC, models available, and their application in the industry. So, let's get started. What is SDLC? SDLC stands for Software Development Life Cycle. SDLC is a process that consists of a series of planned activities to develop or alter the software product. Software Development Life Cycle is a step-by-step process to build or create the software. Software Development Life Cycle is a process used by the software industry to design, develop, and test high-quality software. The SDLC aims to produce a high-quality software that meets or exceeds customer expectations, reaches completion within times and cost estimates. It is also called as software development process. Here you can see the different phases and who are involved in SDLC. First is feasibility study. Is done by the technical architect, finance manager, HR manager, and project manager. Then design. It is done by technical architecture and senior developer. Coding. It is by senior developer and junior developers. Testing. Testing is done by test engineer, QA engineer. Then installation by installation engineer, senior developer. And maintenance by maintenance engineer and BPO. Here are various SDLC models: waterfall model, spiral model, prototype model, iterative model, and V model. Our first SDLC model is waterfall model. The waterfall model was the first process model to be introduced. It is also referred to as a linear sequential life cycle model. It is very simple to understand and use. In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phases. The waterfall model is the earliest SDLC approach that was used for software development. Here, the sequential phases in waterfall model are requirement gathering and analysis. All possible requirements of the system to be developed are captured in this phase and documented in a requirement specification document. Next phase is system design. The requirement specifications from first phase are studied in this phase, and the system design is prepared. Then, coding, with inputs from the system design. The system is first developed in small programs called units, which are integrated in the next phase. Each unit is developed and tested for its functionality, which is referred to as unit testing. After coding, integration, and testing, all the units developed in the implementation phase are integrated into a system. After testing of each unit, post-integration, the entire system is tested for any faults and failures. Then, deployment of system. Once the functional and non-functional testing is done, the product is deployed in the customer environment or released into the market. And the last phase is maintenance. There are some issues which come up in the client environment. To fix those issues, patches are released, and maintenance is done to deliver these changes in the customer environment. Here are some advantages of waterfall model. First, it is simple and easy to understand and use. It is easy to manage due to the rigidity of the model. Each phase has specific deliverables and a review process. Phases are processed and completed one at a time. This model works well for smaller projects where requirements are very well understood. Clearly defined stages, process, and results are well documented. And disadvantages of waterfall model. In this model, no working software is produced until late during the life cycle. High amounts of risk and uncertainty. It is not a good model for complex and object-oriented projects. Poor model for long and ongoing projects. It is not suitable for the projects where requirements are at a moderate to high risk of changing. So, risk and uncertainty is high with this process model. It is difficult to measure progress within stages. Our next SDLC model is iterative model. In the iterative model, iterative process starts with a simple implementation, a small set of the software requirements, and iteratively enhances the evolving versions until the complete system is implemented and ready to be deployed. An iterative life cycle model does not attempt to start with a full specification of requirements. Iterative process starts with a simple implementation of a subset of the software requirements and iteratively enhances the evolving versions until the full system is implemented. At each iteration, design modifications are made, and new functional capabilities are added. The basic idea behind this method is to develop a system through repeated cycles, and in smaller portions at a time incremental. Iterative and incremental development is a combination of both iterative design or iterative method and incremental build model for development. During software development, more than one iteration of the software development cycle may be in progress at the same time. This process may be described as an evolutionary acquisition or incremental build approach. This model also has some pros and cons. Let's check advantages of iterative model. First, some working functionality can be developed quickly and early in the life cycle. Results are obtained early and periodically. Parallel development can be planned. Progress can be measured. Less costly to change the scope or requirements. Testing and debugging during smaller iteration is easy. And disadvantages of iterative model. Defining increments may require definition of the complete system, not suitable for smaller projects. Management complexity is more. End of project may not be known, which is a risk. Highly skilled resources are required for risk analysis. Our next model in SDLC is spiral model. The spiral model combines the idea of iterative development with the systematic, controlled aspects of the waterfall model. This spiral model is a combination of iterative development process model and sequential linear development model, that is, the waterfall model, with a very high emphasis on risk analysis. In the diagram you can see the spiral model has 4 phases. A software project repeatedly passes through these phases in iterations called spirals. The following illustration is a representation of the spiral model, listing the activities in each phase. First phase is identification. This phase starts with gathering the business requirements in the baseline spiral. In the subsequent spirals, as the product matures, identification of system requirements, subsystem requirements, and unit requirements are all done in this phase. This phase also includes understanding the system requirements by continuous communication between the customer and the system analyst. At the end of the spiral, the product is deployed in the identified market. Second phase is design. The design phase starts with the conceptual design in the baseline spiral and involves architectural design, logical design of modules, physical product design, and the final design in the subsequent spiral. Then next phase is construct or build. The construct phase refers to production of the actual software product at every spiral. In the baseline spiral, when the product is just thought of and the design is being developed, a proof of concept is developed in this phase to get customer feedback. Then in the subsequent spirals, with higher clarity on requirements and design details, a working model of the software called build is produced with a version number. These builds are sent to the customer for feedback, evaluation, and risk analysis. Risk analysis includes identifying, estimating, and monitoring the technical feasibility and management risks, such as schedule slippage and cost overrun. After testing the build, at the end of first iteration, the customer evaluates the software and provides feedback. Here are advantages of spiral model. In this, changing requirements can be accommodated, allows extensive use of prototypes. Requirements can be captured more accurately. Users see the system early. And disadvantages of spiral model. Management of project is more complex. End of the project may not be known early. It is not suitable for small or low-risk projects and could be expensive for small projects. Process is complex. Spiral may go on indefinitely. Large number of intermediate stages requires excessive documentation. Next model in SDLC is prototype model. What is prototype model? A prototype is built before the development of actual software. If there is not complete information about the requirements associated with the input and output of a system, it is very important to satisfy the client before developing the software. Therefore, it is necessary to create a prototype model before the final development of a software, because the developer does not have the information related to the system requirements properly. The prototype model is developed to overcome the shortcoming of the waterfall model. Let us see phases in prototype model. In the first phase of the prototype model, information about all the essential needs is taken. The beginning of making any prototype model starts with the analysis of requirements and the requirement of the system. First one is quick design. A preliminary design is created for the system when the requirement is known. It is a quick design and include the elements required for the system. The quick design helps to develop the prototype for the system. Next phase is build prototype. In this phase, initial prototype is developed based on all the information received from quick design. Then, customer evaluation. When the prototype is created, it is presented to the user and provides feedback to the user about what is to be added or removed by developing this prototype. And using the evaluation made by the user makes the system even better. After customer evaluation, review and updation. Once the client evaluates the system to see if it is according to its need and changes to the based on its suggestions. If the user is not satisfied with the prototype, then a new prototype is created and the process will continue until the client is satisfied. And then, review and updation. Once the client evaluates the system to see if it is according to its need and changes to the based on its suggestions. If the user is not satisfied with the prototype, then a new prototype is created and the process will continue until the client is satisfied. Development. Actual software developed based on the final prototype when all the needs are fulfilling and the client is satisfied. In this phase, coding is done, and the software is divided into small modules. Next stage is testing. In this stage, the entire process is tested to see if there is any fault in the system and it is according to the client's requirements. And maintenance. This is the last phase of the model in which the complete system is developed and delivered to the client after all the testing is done. Advantages of prototype model. Increased user involvement in the product even before its implementation. Since a working model of the system is displayed, the users get a better understanding of the system being developed. Reduces time and cost as the defects can be detected much earlier. Quicker user feedback is available, leading to better solutions. Missing functionality can be identified easily. Confusing or difficult functions can be identified. Disadvantages of prototype model. Risk of insufficient requirement analysis owing to too much dependency on the prototype. Users may get confused in the prototypes and actual systems. Practically, this may increase the complexity of the system as scope of the system may expand beyond original plans. Developers may try to reuse the existing prototypes to build the actual system, even when it is not technically feasible. The effort invested in building prototypes may be too much if it is not monitored properly. And our last model in SDLC is V model. The V model is an SDLC model where execution of processes happens in a sequential manner in a V shape. It is also known as verification and validation model. The V model is an extension of the waterfall model and is based on the association of a testing phase for each corresponding development stage. The following illustration depicts the different phases in a V model of the SDLC. There are several verification phases in the V model. Each of these are explained. First step is business requirement analysis. This is the first phase in the development cycle where the product requirements are understood from the customer's perspective. This phase involves detailed communication with the customer to understand his expectations and exact requirement. This is a very important activity and needs to be managed well, as most of the customers are not sure about what exactly they need. Next phase is system design. Once you have the clear and detailed product requirements, it is time to design the complete system. The system design will have the understanding and detailing the complete hardware and communication setup for the product under development. Then, architectural design. Architectural specifications are understood and designed in this phase. Usually more than one technical approach is proposed, and based on the technical and financial feasibility, the final decision is taken. The system design is broken down further into modules taking up different functionality. This is also referred to as high-level design. The data transfer and communication between the internal modules and with the other systems is clearly understood and defined in this stage. With this information, integration tests can be designed and documented during this stage. Next phase in V model is module design. In this phase, the detailed internal design for all the system modules is specified. It is referred to as low-level design. It is important that the design is compatible with the other modules in the system architecture and the other external systems. Then comes the coding phase. The actual coding of the system modules designed in the design phase is taken up. In the coding phase, the coding is performed based on the coding guidelines and standards. And the last but not the least, Validation phases. The different validation phases and types of testing comes in a V model: unit testing, integration testing, system testing, and acceptance testing. V model also have some pros and cons. Then here are advantages of V model. This is a highly disciplined model and phases are completed one at a time. This model works well for smaller projects where requirements are very well understood. Easy to manage due to the rigidity of the model. Each phase has specific deliverables and a review process. And disadvantages of V model are as high risk and uncertainty. It is not a good model for complex and object-oriented projects. It is not suitable for the projects where requirements are at a moderate to high risk of changing. Once an application is in the testing stage, it is difficult to go back and change a functionality. No working software is produced until late during the life cycle. So that was our V model. This is all about the software development life cycle. Hope you have learned from this video. If you liked this video, please do like, share, and subscribe. See you in next video.